Hello, my name is Marguerite Madden. I'm a professor in the Department of Geography at the University of Georgia and the director of the Center for Geospatial Research. And my co-authors are Tommy Jordan and Sergio Bernardez. My talk today is an active learning environment, engaging students in image data collection, analysis, and visualization. My objectives in my teaching is to build a foundation of concepts and theories in geography, such as scale, landscape ecology, and human-environment relationships, along with an understanding and competencies of geospatial technologies, including remote sensing from drone to satellite imagery, photogrammetry, and geovisualization. I'd like to engage students in real-world applications, and one I'll talk about today is human-elephant conflict in the Kavango-Zambezi region of South Africa. The students work with real data, exploring linkages of elephant movements to urban development, local communal farming, and climate change, and hopefully towards mitigation of the conflict and aiding decision makers. I'd also like to note in automation that we remember the power of visualization. Seeing is believing and understanding. Given the need for geospatial imagery processing and products of advanced analyses, from image acquisition to classification to feature extraction, including advanced techniques such as deep learning, I think we also need to remember that it's important to detect and understand the image features before we process. Basic visual image interpretation is critical to automation, modeling, and the assessment, most of all, the assessment of the output quality. We bring our life experiences, perceptions, values, everything we've ever read, places we've been to, we bring that all to our computer screens. And we have amazing brains. We can understand the images, and hopefully we can teach algorithms to do the same. At the University of Georgia, Dr. Sergio Bernardez has led a group of us to develop the 3DIG system, 3D immersion and geovisualization system, using a number of different internal grants from the UGA Center for Teaching and Learning. We start with image acquisition with the drones, do photogrammetric structure from motion processing to create 3D point clouds and models, gaming engines to then bring those models into virtual reality and augmented reality headsets. And also he built an augmented reality sandbox with the help of students. And then the display can be in the sandbox, can be on tablets or on our multi-panel video wall. We fell in love with drones in 2013 when Tommy started buying DJI Phantoms, and we have some Mavic Air, and also the most recent purchase was the Matrice 600 Pro as part of the 3D system. Students are very interested in the technology. We do some hands-on training, we do demonstrations in our classes, we do outreach to the community. This is a class that Sergio put together, and they literally opened the box, took the matrice out, started assembling it, and then also mounting these different sensors. I have to calibrate the data, the image, all the imagery and data are co-registered, and get some real-world experience. This was assessing vegetation damage on Sapelo Island following Hurricane Irma. Most of the vegetation damage was due to salt spray. And creating 3D models. This is a building on campus, and bringing those into the virtual and augmented reality headsets. I believe in the power of the wow experience. It really engages students and inspires, I think, learning everything from the technology and the programming to the applications. Sergio's done a lot of work with working with middle school and even elementary students to introduce them to the technology. And my real-world application is working in the Kavango-Zambezi Transfrontier Conservation Area, the confluence of 5 different countries and national parks. And most of our work is focused in Victoria Falls, which is undergoing a number of different conflicts with wildlife, but especially with elephants. An elephant can come and raid a crop They can destroy a crop in a whole year's of income in one night. They walk down the streets, the main streets. They have attacked people. So the bulls are the biggest problem. Their biological strategy is to get as big as they can once they get kicked out of the family groups until they can be big enough to challenge the bulls that are in the national parks and breeding with the family groups. So we identify problem bulls, dart them, put the GPS collar on them, and we have started in 2015. We have 15 bulls collared and 1 lion. And unfortunately, we've lost quite a few of the bulls to poaching and also cyanobacteria toxicity. But we have a few that the batteries are still working. We get points every 15 minutes and sometimes every hour and sometimes every 12 hours. We can view the data on our mobile apps and see where they are at all times. We also have the data that have been downloaded from the collars. I use them in my classes, and they do a capstone project at the end of the class using the data, looking at the distributions of the different elephants in the wet season. They have to classify the land use and the habitat conditions. They compare that with the dry season movements and patterns. They do animations of their movements over space in 2 dimension in the wet season and the dry season. And then they've also done space-time aquariums to look at the data in 3 dimension. You can see when the elephants are interacting with each other and what their patterns are, whether they're regular or widely distributed or widespread. We're working with the local people. They're growing chili peppers and making mashes of them, and this is a deterrent to the elephants. This is an elephant this is happening now, is raiding the crops there, had been in the airport. They, our team darted them, rubbed it with chili pepper, and he has not been back to the airport since, so it seems to be working. So in conclusion, our classroom concepts, theories, and exercises are developed in the research, students working with real data, and then hopefully moving their findings to actually be used in the community to assist and influence decisions. So thank you for your attention, and also thank you to the Elephant Conflict Research Group, especially the support by Connected Conservation, who helped to house us and give us transportation and buy the collars. And we're a very interested and engaged research group. And here are some references from my work and our students' work. So thank you very much.